Let's do an example problem where we use forces and what we know of Newton's second law to figure out what the coefficients of friction are for a problem. It says we must push a 50 kilogram force with a 50 kilogram crate with a force of 300 newtons in order to make it move. So here I have my 50 kilogram crate, right? I always like to start with the free body diagram, and I'm going to push with 300 newtons of force. And it starts at rest, so this is what I have to apply to make it move. I continue pushing with 300 newtons of force after it starts moving, and that causes it to accelerate at 0.15 meters per second per second. So I have two different cases, so I'm going to draw two different pictures. Right, so this is the part at the beginning where this thing's at rest and I'm just about to put it in motion. So I have the force due to gravity pulling down, I have the normal force pushing up, and I have the static frictional force pulling back on me. And I know these two things are exactly balanced, but as soon as I hit 300 newtons, then it starts to slide. We're supposed to find the coefficient of friction, static friction, and it says max. Remember, this force is going to increase and match this the whole way. So when I first started pulling, it was 100 newtons. This was 100 newtons. Then 200, 200, 300, 300. And now this can't get any bigger. The biggest it can get is 300 newtons. So I'm supposed to figure out what its maximum coefficient of friction is. And generally speaking, we're only ever interested in the maximum coefficient of static friction. So I know that the force of static friction is equal to 300 newtons, because at 300 newtons this thing just starts to slide, so my maximum static frictional force is 300. I also know static friction is equal to the normal force times the coefficient of static friction. So if I find the normal force, which is easy because it's just going to be equal to the weight force since there's no acceleration in the vertical direction, so Fg is 9.8 times 50, and that is the same as Fn. That's 490 newtons. So I know the static frictional force, 300, is equal to 490 times the coefficient of static friction. So if I divide both sides by 490, divide by 490, what I come up with is 0.612, and remember, there are no units on that. That tells me 61.2% of the normal force is equal to the static frictional force. Now, the second part of this problem is a little bit trickier because now we're going to have this thing in motion. So I'm going to redraw my picture, but this time it's not in motion, or not at rest, it's in motion. I'm still applying a 300 Newton force, but now it's sliding, so this is not Fs anymore, it's Fk. I have acceleration this way, and I even know how big that is. That's 0.15 meters per second squared. The mass of my crate is still 50 kilograms, the normal force and Fg still balance, and they're both still equal to 490 newtons. So can I solve this problem? Well, sure. Newton's second law says net force equals mass times acceleration. So the net force is 300, because I'm applying it, minus Fk, and this is all in the x direction, is equal to 50 times the acceleration, 0.15 meters per second per second. Now, I assumed to the right was positive, and I'm only in the x direction here. So now I have 300 minus Fk equals 0.15 times 50, or 7.5. And so then all I have to do is subtract this over and add that over, and I get the force of kinetic friction is equal to 292.5 newtons. Now I'm not done because it didn't ask me to find the kinetic frictional force, it actually asked me to find the coefficient of kinetic friction. But I'm almost done because Fk, the kinetic frictional force, is equal to the normal force times the coefficient of kinetic friction. Since I know the normal force is 490, I know the kinetic friction force is 292.5, I just have to do a little bit of division and we'll have the answer. So 292.5 divided by 490 is 0.597. 0.597. Now stop and make sure that this makes sense. It is a little bit less than my static frictional force. That is what we would expect. It's easier to have something in motion than to keep something in motion. It's easier to keep something in motion than to put something in motion. So my coefficient of kinetic friction should be slightly smaller than static. Everything there looks good. It's just a Newton's second law problem.